Structural Modeling 2.0 Part 1, an application of basic structural modeling and interpretive structural modeling. So this is our second video in the 2.0 series. We'll start going into the details of the new JavaScript program and the details of how the different types of truth are mapped to some of the aspects of that JavaScript program. Again, this is you can download these slides. They're available at my website, which you can get to from this pointer. This is also a pointer to my Twitter feed here, and the charts will allow you to get a more detailed look at the information associated with this video. So we're looking at a 19-city problem, and the overview of that problem is we have 19 cities, which we know them. They're the objects in this particular system. And we have the general relationship that we're going to map over these particular cities to create a system. It's a general relationship of is north of. But we really don't know the specific relationship between a pair of any two cities, so we have to discover those. And we have a set of logical rules that we combine with with empirical data collection. We mark onto the matrix to fulfill the matrix and to order the systems, to order the cities and create the system. And so some of the rules are no city is allowed to be north of itself. And what we're doing is we're using, in this particular case, a strict subordination matrix, which means there's only one city at each level. What that lets us do when we use a strict subordination matrix is that if we know that city A is north of city B, then we know that city B is south of city A. So this allows us to do some more inference and simplify some of the data collection in this particular process. The fundamental concepts and ideas that we're using here, basically there's three types of truth. There's formal truth, factual truth, and value truth. And the factual truth is basic logic types of information and rules that are determined from logical proofs. So factual truth is determined using empirical data. Formal truth is determined using logical inference. And of course, factual truth is determined just by going out and observing the state of the world, doing experiments, asking for information. In this particular case, we're asking which city is north of another city. And then the structural modeling grid encodes factual truth and formal truth on the same grid. And what we do is for factual truth, we have a known and unknown. But we only mark the unknown with the yellow background for factual truth, because the formal truth, which is true, we basically mark that with a 1 with a green background for true. And formal truth, false, which is 0 with a red background. But formal truth is also known. So basically we don't have a known factual truth marking, only a unknown factual truth marking. So we're going to transition here to the JavaScript program. This is the structural modeling grid that we put together to do this type of work. And we start off by clicking this button, which is initialize the city grid. And we initialize the city grid, and what you see is the initial unknown markings for this particular problem. All the yellow zeros are unknown. We really don't know the relationship between those cities. The red zeros on the diagonal, they indicate that this is a false, and we know these are false. So what does this really say? It says, is city 2 north of city 2? And that's a 0 with a red background, meaning false. So we don't allow, logically, a city to be north of itself. So that's why we can mark all the cities on all of the zeros on the diagonal as false, because we do not allow a city to be north of itself. Is city 15 north of city 15? Well, no, that's false. So now that we have all this unknown in the upper and lower triangular area, what we'll do is we'll start collecting some empirical data. And the first set of empirical data we have is City 7 is north of City 1. So we will enter that data into the matrix. We can see City 7 here is north of City 1, and the green 1 for true is in the upper section. So we'll click on that, and then that swaps the rows and columns and brings the green 1 into the lower triangular. What we want to do is we want to have all the 1s in the lower triangular and all the 0s in the upper triangular when we're finished. When it's totally ordered, that will be the pattern. So the next set of empirical data we will get is City 14 is north of City 2. Enter that data. And again, we see we have the green 1 in the upper triangular, and see if it's a green in the upper, click that, and it brings it into the lower triangular where we want all the 1s when we're complete and the system is totally structured. All the 1s will be in the lower triangular. So we can go over and infer information. So this particular function in the JavaScript program web app is available anytime. It is there's not enough empirical data here for inference, so it's not showing us any change than what we have from our empirical data. So we'll go on and collect more empirical data. And the next one we have is City 10 is north of City 5. Put that in there. City 10 is north of City 5. Enter that data. Again, we can see City 10 north of City 5. Green is in the upper triangular section, so we'll click on that, move it back around. Click the inference button. There's not enough empirical data for inference yet. So the next set of empirical data we're going to collect tells us that City 16 is north of City 17. So we'll enter that data. We can see that the green 1 is now in the lower section, so we'll click that in the lower section, and we will go ahead and see if we can infer any information. There's no information to be inferred yet. So the next set of data we're going to collect is City 6 is north of City 19. So City 6 is north of City 19. We'll enter that data. You can see that the green again is in the lower section. Okay, we'll see if we can infer any data. Can't infer any data yet. The next set of empirical data is City 2 is north of City 6. City 2 is north of City 6. Go ahead and enter that data. Again, green is in the upper, so we'll click on that, and that moved all the 1s to lower triangular. Check now. We can see that we've got some inferred data. We have these 3 blue 1s down here. It's inferred information that we can gather from the addition from the set of empirical data we have now. So we have new data points. So the next set of empirical data is City 7 is north of City 8. City 7 is north of City 8. Put that in there. City 7 is north of City 8. Enter that data. So again, we can see the green is in the lower section. The next set of empirical data is City 14 is north of City 6. You can see 14 and 6, we already have an inferred data there, so we don't need to gather that data. Next one is City 12 is north of City 10. City 12 is north of City 10. We'll enter that data. We can see the green now is in the upper, so we will swap swap that back down, but now we see we still have a green in the upper triangular section. We need to move that, so we'll bring up another screen here. This says City 10 is north of City 5. So City 10 is north of City 5. And then we'll move that city data. Now we have everything in the lower triangular. We'll see if we can infer some more, and we can. We inferred a new 1 point there. So that was 12 and 10 that we did there. Let's see, yes. So that city, so that was city 12. Let's find it. Where is city 12? It's 10. So yeah, we just finished that one. So now we're going to do city 18 is north of city 17. More empirical data. We know that city 18 is north of city 17. Okay, we're going to enter that data. Now we can see that the green is in the upper section. So we'll click that and move it back around. So if we can infer more empirical data, we can't do that with that information. City 6 is north of City 13. So City 6 is north of City 13. So that's a good set of data. City 6 is north of City 13. Enter. See, the green's in the upper triangular. So we'll click that, move that around, see if we can infer some more data. And we can infer 2 more data points. So we now have 1, 2, 3, 4, 5, 6 inferred data points so far. So the next one is City 8. City 2 is north of City 8. So City 2 is north of City 8. So that's good. Put that in there. City 2 is north of City 8. Enter that data. Green again is in the lower section. And then we'll move on and collect more empirical data. City 7 is north of City 19. 7 is north of City 19. Enter that data. Green and now is in the lower section again. And City 14 is north of City 17. 14 is north of City 17. Come on, there we go. City 14 is north of City 17. There we go. Enter that data. See if we can infer any more information here. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 points now. And that was 14 and 17. We have that. Next is City 7 and City 10. City 7 is north of City 7 is north of City 10. But obviously we got in a hurry here and didn't do the green was in the lower section. So let's enter that. And now we'll go City 7 is north of City 10. We'll enter that data. We again see that the green is in the lower section. And see if we can infer. Now we can infer some additional information. We're getting some getting more empirical data, so we're now having more opportunities just to infer data. And you can see we just inferred another point. The City 17 is north of City 1. 17 is north of City 1. Put that in, enter the data. The green is in the upper section now, so swap that out. Now we have 2 greens in the upper section, so we'll go have to process that data. So we'll say City 18 is north of City 17. So City 18 is north of city 17. Oops, put those in the wrong place, didn't we? Okay, let's not go up there. Down here, city 18, right here, is north of city 17. So 18 is north of city 17. All right, do move city data. Now we have everything, all the ones and all the green ones and all the blue ones are in the lower triangular section. See if we can infer some new information, and we can. We now inferred some new blue ones in the bottom, and that was 17 and 1 we just did, right? Yeah, 17 and 1. So the next set of empirical data is city 6 is north of city 16. City 6 is north of city 16. Let's enter that data. And we can see that the green is in the lower section. So we'll click that. City 7 is north of city 2. City 7 is north of city 2. Enter that data. Again, the green is in the lower section. And we'll see if we can infer any additional information. And yes, we were able to infer quite a bit more empirical information there. I mean, infer more formal information, not empirical information. All the blue ones are inferred data from using formal logic or formal information. So that was city 7 and 2. Right, so now the next one is city 7 and 3. City 7 is north of city 3. So we'll just enter that. Again, you can see that the green is in the lower section. Let's see if we can infer any more information. One more there. Then city 14 is north of city 1. City 14 is north of city 1. Enter that data. And green again is in the lower section. See if we can infer any more information. We could not. City 10 is north of city 19. City 10 is north of city 19. Enter that data. Again, the green is in the lower section. And we can infer there was another inference point we have there. And city 2 is north of city 17. City 2 is north of city 17. Enter that data. Green again is in the lower section. No more inference potential. Then city 7 is north of city 6. 7 is north of city 6. Enter that data. Again, the green is in the lower section. And we'll see if more inference. City 2 is north of city 5. City 2 is north of city 5. Enter that data. Again, the green is in the lower section. We'll see if we can infer any more information. Yeah, we got an additional one there. And city 7 is north of city 13. Okay, we can enter that data. Again, green's in the lower section. Infer more information. And that's where we're going to cap it off for this particular set of videos. We'll continue from here. In the next set of videos, we stopped with city 7 was north, city 7 is north of city 13. Yeah, so that's where we stop with this one. We'll pick it up there next time. But as you can tell, what we've done is gone through, and this particular case with the structural modeling 2.0 part 1, we've gone through and looked at the 19 cities. We knew those are objects. We've done the general relationship, which is north of. We went through with the discovering, using empirical data, collecting information to find out the relationships, but then also using logic to infer additional data. So the green ones and the red zeros are the outcome from the empirical data we've collected. When we know that, we know it's either true or false. And then the green ones, the blue ones are the outcomes from the inference. So we can infer more information from the data that we've already collected using the factual truth. So we're using formal truth and factual truth in this case. And so we've been through that part, and there's information resources again at the website, and there's also an archive at the website. And this is the end of this particular